This is one of the biggest reasons why your games lag, your videos take forever to render, and your expensive graphics card sometimes performs worse than you expected. Sounds crazy, right? You might have heard people saying, get the graphics card with more VRAM, but then someone else says, nah, the GPU matters more. So who's actually right? Well, here's the surprising truth. More VRAM doesn't always mean more performance. In fact, buying a graphics card based only on its VRAM could be one of the biggest mistakes you'll ever make. So, before you spend your hard-earned money, let's understand what VRAM really is, how it works, and how much you actually need. Let's dive in. Imagine you're playing your favorite game. The graphics look amazing. High-resolution textures, realistic shadows, beautiful reflections, everything feels smooth. But suddenly, the game starts stuttering. Frame rates drop, textures take ages to load, and sometimes objects even become blurry. At this point, most people blame the graphics card, but in many cases, the real problem isn't the GPU itself, it's the amount of VRAM available. So what exactly is VRAM and why does it have such a huge impact on gaming, video editing, AI, and even everyday computer tasks? Let's break it down in the simplest way possible. VRAM stands for Video Random Access Memory. Think of it as the graphics card's own private memory. Just like your computer has RAM, your graphics card has VRAM. But here's the difference. Your system RAM stores data that your CPU needs. VRAM stores data that your GPU needs. Every time your graphics card renders an image, it needs information. Lots of information. Things like high-resolution textures, 3D models, lighting effects, shadows, reflections, particle effects, frame buffers, and even the final image before it's sent to your monitor. Instead of asking your computer for this data every single second, the GPU keeps everything it needs inside its own ultra-fast memory. That's VRAM. Imagine you're cooking dinner. Your kitchen bench is VRAM. The fridge is your computer's RAM. If every single ingredient had to stay inside the fridge, you'd spend half your time walking back and forth. Cooking would become painfully slow. Instead, you place everything you'll need on the kitchen bench before you start cooking. Now, everything is within reach. You cook faster, more efficiently, and with less effort. That's exactly what VRAM does. It keeps everything the graphics card needs right beside it. And that's why VRAM is so important.
So, if both VRAM and RAM store data, what's the actual difference? At first glance, they might seem almost identical. Both are memory, both store information temporarily, and both help your computer perform faster. But they have completely different jobs. Let's imagine you're building a house. The CPU is the architect. The GPU is the construction team. System RAM is the architect's office. It stores blueprints, calculations, instructions, documents, everything the architect needs. But the construction workers don't keep running back to the office every few seconds. Instead, they keep the tools, bricks, cement, and materials right beside them. That's exactly what VRAM is. It's the GPU's personal workspace. Everything the GPU needs is already waiting there, so the GPU doesn't waste time asking the CPU for data again and again and again, because every extra trip means lost performance. Imagine you're playing Cyberpunk 2077. You're driving through a massive city. Buildings appear, cars appear, road signs, reflections, NPCs, explosions. Thousands of textures are loading every second. Your graphics card has milliseconds to prepare the next frame. If every texture had to come from system RAM, the GPU would constantly wait. Frames would drop, games would stutter, loading would become much slower. That's why VRAM exists. It's incredibly fast, and it's located right beside the GPU. Now, let's look inside your graphics card. Think of the GPU as an artist. Every second, that artist has to paint dozens, sometimes hundreds of pictures. Those pictures are the frames you see on your monitor. Before drawing each frame, the GPU needs information. What texture should this wall use? Where should the light come from? How shiny should this car look? Where are the shadows? How far is that mountain? Every single answer is stored inside VRAM. The GPU grabs the information, creates the image, and sends it to your display, then immediately starts working on the next frame. This happens 60 times a second, 120 times, 240 times, or even more. That's why modern VRAM is incredibly fast. Some graphics cards can move hundreds of gigabytes of data every second. Without that speed, modern games simply wouldn't exist. Now, here's something that confuses almost everyone. Open Windows, look at your graphics settings, and you might see something called dedicated VRAM and shared GPU memory. Many people think, great, my graphics card has 4 gig VRAM plus 8 gig shared memory, so I have 12 gig VRAM. Unfortunately, that's not how it works. Dedicated VRAM is real memory physically built onto your graphics card. It's extremely fast. Shared memory isn't real VRAM. It's simply your computer borrowing some of its normal RAM when absolutely necessary. And remember, system RAM is much slower for graphics work. So if your GPU starts relying heavily on shared memory, performance usually drops. Games may stutter, frame times increase, and loading textures become slower. That's why 4 gig dedicated VRAM is far more valuable than 4 gig shared memory. Never confuse the two.
So we've learnt what VRAM is. We've learnt how it works. Now let's answer the question everyone asks before buying a graphics card. How much VRAM do you actually need? The answer depends on what you do with your computer. Let's start with 4 gigabytes of VRAM. A few years ago, 4 gigabytes was perfectly fine. But today, many modern AAA games can easily use more than 4 gigabytes of VRAM, especially at higher graphics settings. If you're only playing lightweight games like Valorant, League of Legends, Rocket League, or Minecraft, 4 gigabytes can still get the job done. But for newer titles, you'll probably need to lower texture quality to avoid stuttering. Now let's move to 6 gigabytes of VRAM. This is a much more comfortable starting point. For most 1080p gamers, 6 gigabytes handles the majority of modern games quite well. Then comes 8 gigabytes of VRAM. For many people, this is the sweet spot. It offers a great balance between price and performance. Most modern games at 1080p and many at 1440p run smoothly without constantly running out of memory. Next is 12 gigabytes of VRAM. If you edit videos, work with large creative projects, play demanding AAA games, or use AI apps, 12 gigabytes gives you much more breathing room. Finally, there's 16 gigabytes or more. This isn't just for gaming. It's ideal for professionals, 4K video editing, 3D rendering, machine learning, game development, and anyone working with huge textures or complex projects. So, more VRAM can definitely help. But here's the mistake many people make. They think more VRAM automatically means a faster graphics card. It doesn't. Imagine 2 graphics cards. One has 12 gigabytes of VRAM, the other has 8 gigabytes of VRAM. Which one is faster? Most people immediately choose the 12 gigabyte card, but that's not always correct, because VRAM is only one part of the graphics card. The GPU chip itself, its architecture, its processing power, its memory bandwidth, its clock speed, all of these matter just as much. Think of it like a delivery truck. VRAM is the size of the cargo area. The GPU is the engine. A truck with a huge cargo area but a tiny engine won't necessarily arrive faster.
Sometimes, a smaller truck with a much stronger engine finishes the job first. The same thing happens with graphics cards. Never buy a GPU based on VRAM alone. Always look at the complete picture. So, which one should you choose? If you mainly browse the web, watch YouTube and play lighter games, you don't need massive amounts of VRAM. If you're a serious gamer, aim for at least 8 GB if your budget allows. If you're editing videos, creating 3D content or working with AI applications, you'll benefit from 12 GB or more depending on your software and workload. And remember, buying the most VRAM isn't always the smartest choice. Buying the right balance between GPU performance and VRAM, that's what gives you the best value. So, now you know exactly what VRAM is, how it works, why it's important, and how much you actually need. The next time someone says, just buy the one with more VRAM, you'll know it's not that simple. If this video helped you understand VRAM, give it a thumbs up, subscribe to All About Tech, and let me know in the comments how much VRAM does your graphics card have, and is it enough for what you do? Thanks for watching, and I'll see you in the next one. Technology made simple.